So today we're going to cover Chapter 1, Section 2B. So we did 2A on Friday. Today we're going to be solving rational equations. So we did some of these on Friday, or I think one of them, where we had to clear the fraction. So this is what we're going to do. We're going to eliminate the fraction by multiplying by the LCD. Now, when it was expressions, and we were simplifying those expressions that were rational expressions, we had to keep the LCD. Here, we're trying to find the LCD and then multiply each term by that LCD to get rid of the denominator. Now, what's different from this section than from the part A, whenever there's a variable in the denominator, we need to check to see if our answer is an extraneous root, meaning it would make the denominator undefined if it ends up becoming a 0. So when there's a variable in the denominator, the check is mandatory. Now, as far as the check goes, you don't have to plug in the number and check to see if it simplifies to the other side of the equal sign. You can still do that to make sure your answer is good. What I mean by checking for extraneous solutions or roots is to make sure that once we plug it into the denominator, it doesn't make it become a 0. So let's try some examples. So this was very similar to what we did last week. What I'm going to do here is find my common denominator, or my LCD, and I need to multiply each one of the terms by that LCD to get rid of each of the denominators. Now, you can either choose to say, okay, my LCD between 3 and 4 is going to be 12, and you could show that I'm just going to multiply and distribute 12 to each thing. What I like to do is take the 12, put it next to each one of my fractions, so x over 3, and then the next one, I'll put it next to, put a 12 over 1 next to this one. You don't have to do this. You could just distribute it to everything. But what I was seeing last week, I saw some of you guys forgot that you had to also distribute it to the numbers that didn't have a denominator. I'm still distributing it to the 2. And notice nothing would simplify there. So now what I'm doing here is I'm simplifying, and then this becomes a 4. 12 divided by 3 is 4, so 4 times x is 4x. Over here, the 12 and the 4 will simplify, and this becomes a 9x. And then here, the 12 times 2, nothing simplifies, so it's 24. Now I need to begin my solving process. I'm going to go ahead and combine my like terms here. 4x plus 9x is 13x equals 24. Divide both sides by 13, and x equals 24 over 13. What we saw last homework, the 1.2a, remember you can enter a fraction with that slash. Now, no check is necessary here because notice my denominators, they're not variables. So I don't have to do the mandatory check here. This is a good answer. It is not going to be extraneous. Now, you could still do the check. You could plug that in to see if it equals 2 once you replace x with 24 over 13. But again, it's not mandatory because there is no variable in the denominator. Let's try the next one. Again, I'm going to look for my common denominator, or my LCD. And between 5 and 3, it's going to be 15. So again, I'm going to write the 15 next to each one. So 15 over 1 times the 2x over 5 plus, and then I'll move to the next one, multiply the 15 to the 5x, and then lastly, multiply the 15 times the 4 over 3. Again, you don't necessarily have to do this. If you would rather just show that you're multiplying 15 to the whole equation, and then just remember, you got to distribute it here, here, and here. you can do it that way as well. This gives me a little visual though, so I can see what cancels. So for the first one, I can simplify the 15 and the 5. This becomes a 3. So then this becomes 6x. Then nothing to simplify here in the middle. So this becomes 15 times 5 is 75x. And then here, this will simplify. And then 5 times 4 is 20. I'm going to combine my like terms. 6x plus 75x is 81x equals 20. I'm now going to divide both sides by 81. And x equals 20 over 81. Nothing simplifies here, so that is your final answer. There is no variable in the denominator to check for the extraneous solution. So this is a good answer. So for number 3, I'm going to look for my LCD between 5, 2, and 10. And that LCD is going to be 10. So I'm going to multiply each one of my fractions by a 10. So again, I'll go ahead and do the first one. So 10 over 1 times the x over 5 minus 10 over 1 times the x over 2 equals 10 times the 3. And then I have an extra term here. And then again, 10 over 1 times the 3x over 10. So again, this will simplify. And this becomes a 2x. And then here, the 10 and the 2 simplify. Becomes a 5. Equals 10 times 3 is 30. And then the orange, it cancels, and you're just left with 3x. Now I have variables and on both sides. So I need to combine my like terms here first. So 2x minus 5x is negative 3x. And then now I'm going to go ahead and move my 3x over by subtracting it. And I end up with negative 6x equals positive 30. Divide both sides by negative 6. And x equals negative 5. Again, there was no variable in the denominator, so the check here is not mandatory. So this is a good answer. Now with number 4, notice we have x's in the bottom of our fractions. This one, after we get our answer, we need to do the check. Now, one thing you could do is you can take what's in the denominator to begin with. So I could take, it's just an x. So if when I'm done, what you could do is you could say, if x equals 0, then it's going to be a bad answer. So what you could do is take what's in the denominator, set it not equal to 0, and that's what x can't be. But let's go ahead and try it. So again, I'm going to get rid of my denominator. My denominator is going to be x. So I'm going to multiply each one of my terms by x. So I'll do the first one, 15 over x minus, and then the next one, x times 4, and then equals, and then the next one will be x times 6x, 6 over x, and then finally the last one, x times the 3. So for the first one, the x's cancel, and you're left with 15. Over here, it just becomes a 4x, and then the equal. The purple x cancels, and you're left with just 6. And then for the orange, just multiply 3 times x. Now we have something that looks like the 1.2a, where we have variables and numbers on both sides. So I need to work to get my variables together. Now, it doesn't matter what you move first. I'm going to go ahead and, instead of moving my variables to the left, I'm going to add the 4x to the right side. It doesn't really matter. And then next I'll move the 6. And then I get 9 is equal to 7x. And now I got to divide both sides by 7. And my final answer here is x is equal to 9 over 7. Now, when I plug it in, it doesn't make my denominator 0. I can put a 9 over 7 here, and it's not a 0. So this is a good answer. It is not extraneous. So what you're doing is you're getting your value of x that you solved for. If when you plug it into the original problem, if it makes the denominator a 0, you can never divide something by 0. That is undefined, so that's why you can't work the problem out, because division by 0 is undefined, which would make that solution extraneous. So here, plugging in 9 over 7 for x, it just makes the denominator here 15 over 9 over 7. This isn't a 0, it's okay. Same thing when I plug it into the 6 over x. When I put in 9 over 7 here, it just turns into 6 over 9 over 7. I can divide 6 by 9 over 7. It'll just be a fraction. It's not undefined. So let's try number 5. Now, whenever I see anything that looks like this, I treat this as a proportion. Now, you could still go ahead and do it the same process, find the common denominator, but whenever I have two fractions equaling each other, I'm just going to do the cross products. I'm just going to multiply this times 1 and then distribute the 2 to both of these. It makes it a lot easier. So here I'm just going to do the 1 times the 5x plus 6 and set that equal to the 2 times the 10x plus 3. I'm going to distribute the 2. The purple, it just 1 times anything is itself. And then over here becomes 20x plus 6. And now I need to get my like terms together. It doesn't matter which way you move things. Last time I moved the variable to the right, I could move this over to the left. Yes, I'm going to get a negative 15x, but that's okay. And then now subtract the 6. And then now I get negative 15x equals 0. Divide by negative 15. Now, when the 0 is in the numerator, 0 divided by anything is just 0. Now, once you get your answer, we have to look. Is there a variable in the denominator in the original problem? Yes, there is, but when I plug in 0 into the 5x plus 6, it doesn't make that denominator 0, it just makes it 6. So this one's okay. X equals 0 is a good answer. It did not make this denominator equal 0. If I would have just had like 5 over x, then it would have made that denominator a 0, and then I would have thrown out that answer, and my solution would have been no solution. But this one works. One thing you could have done from the very beginning is, as soon as you see you had a variable in the bottom, you could have taken that 5x plus 6, set it not equal to 0, and the only value of x that would make that undefined is x cannot equal negative 6 over 5. If it did, then that denominator would have been a 0. So this is the other way you could do it ahead of time. And then if you would have gotten negative 6 over 5 as your answer, then you would have known it was no solution. So you can do it either way. Let's try the next one. So for this one, I'm going to go ahead and multiply everything by my LCD. My LCD is going to be the x times the x minus 5. So then I'm going to multiply that to this first one, the 1 over x. Then I'm going to multiply it to the next fraction, the 2 over x minus 5. And then notice here, I've got equal 0. I still need to show that I am multiplying it to the answer as well. But honestly, 0 times anything is just 0. So this is just going to become a 0. Then over here, the blue, the x's cancel. And then you're just multiplying 1 times the x minus 5. Then over here, the x minus 5 cancels. And then you're going to multiply the negative x times the positive 2. Should be a plus sign. That's a plus sign. So this is a plus. So positive x times positive 2 is 2x. And then it equals the 0. Let me go ahead and move that over. It's a little bit far away. So 0 times the x times the x minus 5 is just 0. And now I can begin my solving process. Combine your like terms. X plus 2x is 3x. We're not moving anything across the equal sign. We're just combining like terms first. Now I'm going to begin my opposite operations. So to move the 5, I add 5 to both sides. And then 3x equals 5. Divide by 3. And x equals 5/3. So now let me check it because I had variables in both denominators. It was 1 over x plus 2 over x minus 5. So all I'm doing is plugging in this value of x in here to see if it makes any of these denominators a 0. So when I plug it in here, this just becomes 1 over 5/3. It's not 0, it's good so far. And then over here, I'm going to do 5/3 minus 5. It doesn't make it 0, it makes it a negative number. So this answer is good, it's not extraneous. It did not make any of my denominators a 0. Again, one thing you could do from the beginning, if you wanted, take your two denominators. X can't equal 0 for the first fraction. And for the second one, x minus 5 not equal to 0. So if you would have gotten 5 or 0 as an answer, then the answer would be no solution. Let's try the next one. So my LCD here is going to be both. So again, if you don't want to show it in front of each one, you don't have to. Just makes it easier for me to see what cancels. So I'm multiplying it by 2x plus 1 and 2x minus 1 to each one of the fractions. Minus, and then put it here, 2x plus 1, 2x minus 1, then the fraction. And you have to remember to do it to the answer as well. So 2x plus 1, 2x minus 1, and then it's multiplied to the negative 4. Now, if it's better for you to change this to a plus and make the 8x negative, you can do that. So now what I'm going to do here is look to see what's going to cancel out. So the x plus 1 cancels. So here I'm just distributing the 7 to the 2x minus 1. Here the x minus 1 cancels, or 2x minus 1. So then I'm going to distribute the 8x to the 2x plus 1. And then for the last one, nothing cancels. So I'm going to FOIL this first, and then I'm going to distribute the negative 4. So once I FOIL that, I end up getting 4x squared minus 2x plus 2x minus 1. I still have the negative 4 here. Notice these guys cancel out. So then now I'm just going to have to distribute 4x squared minus 1 with the negative 4. And this ends up giving me negative 16x squared plus 4. And then let me drop down the rest of the problem after I distribute. So I have to distribute the blue. This gives me 14x minus 7. This one's going to give me negative 16x squared minus 8x. Now I'm going to combine my like terms here. So I have a 14x and a negative 8x. So now I have negative 16x squared plus 6x minus 7, and it equals this negative 16x squared plus 4. Notice when I try to group my 16x squareds together, they're going to cancel. So that's gone. So now I'm left, let me come over here to the side. So now I have 6x minus 7 equals 4. Add the 7. 6x equals 11. Divide by 6. And x equals 11 over 6. Now, we have to do the check because we had variables in the bottom. What's probably going to be easier is if you took the two denominators, the 2x plus 1, set it not equal to 0, and the 2x minus 1, set it not equal to 0, and this will tell you what x can't be. So x cannot equal negative half and positive 1/2. So if we were to have gotten positive or negative 1/2, then our answer would be extraneous. So this is one way you can do it, or we take this and then we take our two denominators, the 2x plus 1, replace this, 2 times 11 over 6 plus 1. Well, this is going to give me 22 over 6 plus 1. It's not 0. So it works there. This is the other way to do it. And then take the 2x minus 1, 2 times 11 over 6 minus 1, 22 over 6 minus 1. Again, it's not giving me 0, so this is a good answer. Now for this one, we need to factor the denominator first. Otherwise, if you say your LCD is x minus 2, x plus 2, x squared minus 4, you're going to have a big, ugly problem. So what you need to do is factor this guy first, x minus 2, x plus 2. That's your LCD. And notice this one's already got part of it, and so does this one. So again, you're going to take that LCD, and it needs to get multiplied to each one of the terms. So if I take my first one, and I multiply it by x minus 2, x plus 2, and then multiply it to the 1 over x minus 2, equals, and then now take the same LCD again, multiply it to that 3 over x plus 2, then I have the minus 6, so I could do this, or let me just do this. Show the LCD, x minus 2, x plus 2, and then times 6x over, and then it's factored, and you can make this negative 6x because I did key flip change. All right, so now this cancels, the x minus 2. So then now 1 times x plus 2 is just x plus 2. Then I've got the equal sign. Then the purple, the x plus 2 cancels. So I have to distribute the 3 to the x minus 2. And then for the blue, it already had the denominator. So then I just put the minus 6x. And now I need to distribute the purple. The purple becomes 3x minus 6. Drop down the blue, the red. Combine your like terms first. So when I combine these two, this gives me a negative 3x minus 6. And now begin your solving process. I'm going to add 3x to both sides. I get 4x plus 2 equals negative 6. Subtract the 2. 4x equals negative 8. Divide by 4. And x equals negative 2. So now we got to check it. So remember, your denominators were x minus 2, x plus 2, and x squared minus 4. So if I plug it into this one, I get negative 2 minus 2. It's negative 4. That one's okay. When I plug it in here, this one, the second fraction, gives me a 0. I don't even need to check the last one, but it will also give me a 0. So this answer of x equals negative 2 is extraneous. This is an extraneous solution. So the answer here is no solution, DNE, does not exist. If I come back up here to my original problem, and if I put a negative 2 here, this makes this denominator equal 0. I can never ever divide something by 0, so this problem is undefined just because of this one fraction, because 3 divided by 0 is undefined. Good? Now, you could have done the thing at the beginning where you set each of the denominators not equal to 0. And if you would have gotten x equals positive 2, or this one, solve this one, not equal to 0, and x cannot equal negative 2, which is what we got, so that's why this answer is no solution. It's a lot of work. Let's try 4 more examples, and we're done. All right, so for number 9, notice my LCD is the x minus 4. The only one that doesn't have it is this middle one. Now again, if you don't want to do like I've been showing you all along, you can show that you're multiplying everything by the x minus 4. So that would cancel this one, but this one would need to get it to distribute, and it cancels this one. So if you didn't want to show that you're doing it to everything, you don't have to. I like doing it because it helps me to cancel. So then this is just going to be 3x equals 5 times the x minus 4 plus 12. Distribute. Combine your like terms. So this gives me negative 8. And now move the 5. Subtract 5x. Negative 2x equals negative 8. Divide by negative 2, and x equals positive 4. We must check it. Remember, look at my denominator. It's x minus 4. Soon as I plug in a 4 there, I get 0. So this answer is no solution. 4 will make this problem undefined. So does not exist. All right, so the next one. So I'm going to go ahead, and my LCD is the x minus 1 and the x plus 3. So x plus 1 times x plus 3. And I'm going to write it next to this term, the 12 over x minus 1, x plus 3. Then equals, I need to write it next to the next one, x plus 1, x plus 3, next to the 3 over x minus 1. And then do the same thing here, x plus 1, x plus 3, and then put it next to the 2 over x plus 3. Okay, so for the first fraction, it actually cancels away both. So then I'm just left with 12. The red one only the x plus 1, that should have been a minus 1. Let me go back on all these. These should be minus 1s. And there should be a minus 1, not a plus. That's a plus 3, but that's a minus 1. All right, so the minus 1 cancels. And then now I need to distribute the 3 to the x plus 3. Then I have the plus sign. And then now I'm going to distribute the x plus 3 cancels. So then I distribute the 2 to the x minus 1. All right, so I have to distribute the red. So the blue stayed. The red becomes 3x plus 9. The purple becomes 2x minus 2. Next, I'm going to combine my like terms. So 3x and 2x is 5x. And then 9 minus 2, that's going to give me 7. Now I can begin my solving process. Subtract the 7. 5 equals 5x. Divide by 5. And x equals 1. Now, let's go back and look. My two denominators were x minus 1 and x plus 3. Soon as I plug in 1 here for this x, it makes this first fraction, this part is 0. So this is no solution. It makes the fractions undefined. DNE does not exist. So number 11, we need to, okay, so here I got to factor it. So this will factor into x minus 2, x plus 3. Bye. All right, so here, I'm going to write it next to each one. So the first one, x minus 2, x plus 3, next to the first fraction. Then the next one, I'll write it here, x minus 2, x plus 3 times the 3 over x plus 3. I'm just putting it on top of each other just to save room here, but no, it should be long ways. And then finally the red, x minus 2, x plus 3 times the 4 over x squared plus x minus 6. So for the blue, the x minus 2 cancels. So then now you're just going to multiply the x plus 3 to the 1. Then for the purple, that one cancels. So you're going to multiply 3 times x minus 2. And then for the red, they both cancel, and you're just left with 4. I need to distribute the purple. So the purple becomes 3x minus 6. I'm going to rewrite the rest of the problem. I'm going to combine my like terms here. So x plus 3x is 4x. And then I'll combine the 3 minus 6, gives me negative 3. And then it equals the 4. Add the 3. 4x equals 7. Divide by 4. And x equals 7 over 4. Now, when I plug it in, it does not make any of my denominators a 0, so it checks. Because the first fraction, in order to make this one a 0, that would have had to have been a 2. To make this one a 0, it would have had to have been a negative 3. So 7 over 4 does not make anything undefined. And then the last one, factor the GCF out first. And notice this fraction already has the x, this has the x plus 3. So then, again, multiply all 3 of them by the x times the x plus 3. So x times x plus 3 multiplied to the 6 over x. Then here, x times the x plus 3 needs to get multiplied to the 2 over x plus 3. And then the last one, x times the x plus 3, and then it's multiplied to the 3x plus 5 over x squared plus 3x. All right, so let's look to see what cancels and what we have left to distribute. So the blue, just the x cancels, so I have to distribute the 6 to the x plus 3. Then for the red, the x plus 3 cancels, so you just multiply the 2 times the negative x, or the negative x times 2. And then the purple, the whole thing cancels. So then you're just left with what was originally there, the 3 times the x plus 5. So I have to distribute the blue and the purple. So let me just bring it straight down so it's not in the color. 6x plus 18 minus 2x equals 3x plus 15. Going to combine my like terms. 4x plus 18 equals 3x plus 15. Move the 3x. X plus 18 equals 15. Move the 18. X equals negative 3. I need to check. And when I check it, my denominator was an x and an x plus 3, and then the x squared plus 3x. So if I plug it in here, this one's okay, but as soon as I plug it into this one, I get 0. So this is no solution, does not exist.